This is Duke University.
And now I'll turn to the subject of Duke medicine. You know, do you know that when Mr. Duke was offered the chance to bestow his name on Trinity College, he had two choices. For one sum, you could have a university without medical school, but then he wanted to know how much extra is it for a medical school. Please remember, when you're disposing of your personal estate at the end of your life, to ask questions of this sort. And so it was that in 1930, out of the middle of a forest was hewed what became one of the world's great medical schools that had not only not been a good one, it had not been anything before that, and it all came into existence in the lifetime of people still alive. And so that's been a source of pride for us to be a place not only for great medical research, for the training of great healthcare givers, and for the care of patients at a great level. And we'd like to move that forward as we do everything else. In this respect, I think one of the great events of this year and of the month of February was the dedication of the new cancer center on campus and on the middle of the health campus. You know that people who have cancer have to have all kinds of things done to them that are already difficult and distressing and unpleasant. But if you have to keep running from one place to another, and you know the parking meter runs out, and now you have to have a blood drawn over here and all of that, what if you were to create a place that was designed in terms of the experience of patients to make all the things that could be made convenient as could be, all the things that could be made pleasant as could be. So we have opened not just a place for the highest levels of treatment, but a place for the highest levels of consideration of the people undergoing the treatment. So that's part of something we have to be proud of. But of course, the opening of the building is only the most visible part of the story. We are also in the process of reconstructing the whole way we study cancer at Duke, breaking down departmental structures, trying to bring groups of faculty together, and trying to make our university an absolute center in the lead of unfolding the mysteries and addressing the problems of cancer. In this regard, we had the great good luck to hire someone to head our center. The person we hoped against hope we might get, we got. And guess what? He is from Charlotte. His name is Michael Kasten. He went to East Mecklenburg High School, where you were a class officer of some sort. I'm sorry, I've forgotten the illustrious early high school part of your career. I'm told that people who knew him in high school are in this room, and that some of his teachers are actually here, which just makes me, the rowdies are starting to weigh in already, Mike. After he went to high school in Charlotte, Mike Kasten went to UNC. He was a Moorhead scholar. Even I am impressed by things like this. He then went after a great undergraduate career, he went to the great medical school at WashU, where he got his MD and PhD. He then worked at Hopkins. Along the way, he was becoming one of the really famous and important researchers in cancer and helping to understand the mechanisms by which the parts of the cell or the actions of the cell by which DNA is injured and repairs itself, and the role of those things in cancer. He then was asked to assume administrative responsibilities together with his scholarly ones. He has headed the Comprehensive Cancer Center at the very famous place in Memphis called St. Jude. And to my great happiness, when he was asked if he would come head our new cancer institute at Duke, the answer was yes. So this is the latest and one of the greatest moments in the history of Duke-Charlotte collaboration. So may I invite Mike Kasten to come up and be with me. That's good. Yeah. Okay, so I'm going to interview this guy a little bit. And he doesn't know what I'm going to ask him. In fact, his office supplied my office with a list of questions he hoped I would ask, and I don't intend to ask a single one of those. So let's just go at this. And I am going to ask you a question to which I actually know the correct answer. So you were born in Charlotte?
No.
But
I was born in Brooklyn, New York, and moved to North Carolina when I was 4 years old. Lived in Newton for a year and a half, Statesville for 4 years, and then Charlotte. But I grew up in Charlotte, and I consider it my hometown.
And are you going to tell me the pathway that led from Brooklyn to the Charlotte region?
My father was in the hosiery business, and North Carolina was where the mills were. So this was where he had his opportunity to make his way up in the company.
Okay. So all of a sudden so what age were you when you came from Brooklyn?
4.
You must have been the only person with a Brooklyn accent in the greater Charlotte area. Okay.
No, there were 3 others, my sister and my parents.
And I'm sure at home you practiced the accent to keep it from being, okay. But eventually you lived in Charlotte and you went to high school here. Yeah, as you look back, what part did that have in the launching of your career?
I am who I am because of the experiences I had growing up in Charlotte. It started with, and if Joan is here, outstanding education at East Mecklenburg. The teachers there were absolutely wonderful in every discipline. Mm-hmm. But I had phenomenal science teachers in biology and chemistry, tremendous math teachers, and that started me on the way. But the real turning point for me was an opportunity to work at what was then Charlotte Memorial Hospital. Many of you probably know Francis Robacek and the cardiac research laboratory he had there. When I was in high school, I had the good fortune of working in that laboratory.
When you were still in high school?
When I was in high school. And there I learned the power of research. In fact, the story is quite remarkable. It was actually a lab where we did research on dogs, and actually I'm quite an animal lover, and it bothered me initially to think about doing research on dogs, but I realized we were picking up the dogs at the pound the day they were going to be put down, and if you've ever seen the way dogs are put down at the pound, it's one of the most inhumane things.
Don't go there.
And so we would bring them to the lab, and they would live for however long before they were used for these cardiac research experiments. I actually took one of the dogs home, much to my mother's chagrin, and he became our pet. But one day when I was looking through the old records in the lab, I found that this laboratory in the late 1950s had done research on Dacron grafts, which are these synthetic grafts that replace big blood vessels when, as you age and you have problems with your blood vessels, this is a way to replace them. And I was struck. I said, wow, I didn't realize this laboratory had done such important research back in the 1950s. And the next day, Dr. Robacek came down to the lab and said, Mike, would you like to go see a surgery in the operating room? I said, oh, I'd love to. I've never seen surgery. And I walked into the room, and on the table was a 38-year-old woman who had just given birth, and after the delivery had an abdominal aortic aneurysm, a ballooning of her major artery, and they put in a Dacron graft to save her life. And it just hit me like a lead balloon. These dogs gave their lives to save this woman. And I realized the power of research, and I realized how with research you not just save one patient at a time, you actually make an impact on society as a whole. So I was convinced that that had to be the direction that I'd had. So it was an incredible experience for me, and I knew I wanted to do medicine, but that directed me towards research. Cancer was a slightly different.
So that's what I want to ask you next. Because, so far, everyone who goes on in this kind of field, everyone in the world who has the luck to have good teachers, that's the beginning of everything. But then I find it interesting that you had something else, something that brought biology and chemistry to a sense of the sort of immediacy of what that kind of abstract, distant intellectual work could actually do for people. How did you find, at some point you found that you were going to spend your life working in the study of cancer?
One of the changing events for me was actually working for the Mecklenburg County board, the American Cancer Society Board of Directors in Mecklenburg County. I was the student representative on that board. And so I was very involved in fundraising for them. And in fact, the fundraising campaign was called Send a Mouse to College. I don't know how many of you may remember that. These were little buttons we used to go around wearing while we were collecting money, and had all the little coin boxes in movie theaters and fast food chains. And it was to support research. So that
even
sort of
by the
drove
time
me
you got to
towards
college, you already knew that you were interested in cancer?
Yes, I knew I wanted to do research, and cancer seemed to be the problem that needed the most attention at the time.
Well, everyone in this room knows, as other causes of mortality declined in the 20th century, cancer came forward to be what, the first or second largest cause of death in this country. I read a book, and I told you that I had this winter, some of you may have seen it, called The Emperor of All Maladies. That's a history of the attempts to understand cancer. And one of the interesting things you learn in it, if you're a certain age, you'll remember when Richard Nixon launched the war on cancer. And the idea was, if you could put a man on the moon, surely you could find the cure for cancer. And one of the points that the book makes is, when that was launched, which must have been about the time you were finishing high school, that war was never going to succeed because people didn't understand the underlying mechanisms of cancer at that time. So to me, that has the really interesting point when I look at you, which is, all right, to the extent that we do understand those underlying mechanisms, that understanding was achieved in your adult lifetime.
Yes, it's been an extraordinary 40 years, but the point you make is a very good one. The National Cancer Act was signed in 1971, and the first National Cancer Institute-supported cancer centers were in 1973. Expectations were very high that this would be a curable disease in a very short period of time, and it was an extraordinarily naive consideration. And frequently when I'm giving talks, I show a cartoon to make this point. This is a Gary Larson cartoon of cavemen looking through their hands at rocks, and underneath it says, "Early microbiologist." And when I show that cartoon, I say, this is where we were at when the war on cancer was declared in 1971. We didn't have the knowledge base to know what questions to ask, and we didn't have the technology to even ask the questions. This has all changed over the last 40 years. What's happened in the last 40 years is we've learned a tremendous amount about the difference between a normal cell and a cancer cell. And now we can finally start using very specific therapies rather than the very toxic, non-specific therapies. And we're at a cusp. The whole field is full of excitement because of the potential now for developing very specific, very effective, non-toxic therapies. And it's challenging because it's happening at exactly the time that federal funding is dropping off, that big pharmaceutical companies are stopping their research and development because it's challenging for them from a financial perspective. And it's very challenging to make that transition from those basic discoveries into patient care. And in many ways, this is what the Duke Cancer Institute was developed to address.
Well, people had ways to attack cancer, radical surgery, chemotherapy, long before they understood the underlying mechanisms, right?
Correct.
And now you're talking about a much more focused and particular, instead of doing a lot of collateral damage to try to cure some ill thing, of a much more focused kind. So, okay, this is the hardest question I will ask you. After this is all easy street for you, which is, you've spent your whole life, this guy is famous for his discoveries in science, but one of the hardest things for anybody in any academic field to do is to explain to the ordinary intelligent person, what was the thing you found? What was the thing that you are so celebrated for? So I truly want to ask you, without modesty, okay? Let's pretend he's already said, "Aw, shucks, what I did wasn't too important." But can you tell us what the work is that you yourself are famous for, or well known for?
So, as a general field, what I study is how our DNA gets damaged by exposures to things in the environment and by our own metabolism. Our DNA is constantly being damaged. The DNA is the brains of the cell. It's what controls how cells behave. And we know that what cancer is a disruption of that DNA. So what I've spent my career studying is how that DNA gets disrupted, both by natural processes and by exposures to radiation, to chemicals, sunlight. And so I've studied a lot of the molecular mechanisms that control how cells respond. And when they are disrupted, that's when you get a cancer. What set my career on its current path was an almost serendipitous discovery when I was a new faculty member at Johns Hopkins, where I found that a particular gene called P53, which some of you may have may have heard about in the past, played a critical role in helping cells respond to damage. When your cells get irradiated or you get exposed to a chemical, the p53 gene turns on and it either kills the cell or it tells the cell to stop growing to allow it to repair. When p53 doesn't function, then the cell mutates and it goes on to become a cancer cell. And we made this discovery right at the time that p53 was found to be the most commonly mutated gene in human cancer. So all of a sudden, a lot of things fit together. That here was this gene that we know when it's mutated, you get a cancer. We figured out what it did and why that occurs. So it started me on a path of studying these pathways that help cells respond to damage. And now we're to the point where we know these pathways well enough that we're designing drugs that can manipulate them to prevent cancer, to prevent the toxicities of chemotherapy, and to make tumors much more sensitive to chemotherapy and radiation therapy.
It's incredible. And as you say, then in your career, you worked in labs and made these discoveries, but then you began to have the larger responsibility that had to do for research and cure, research and therapy at the same time. St. Jude is a comprehensive cancer center, and so is Duke. Okay. St. Jude is a very, very famous place in this field. Can you give me an answer to the question how you came to come to Duke?
Apart from...
You need not engage in any further modesty.
Apart from the extraordinary pull of moving back to North Carolina after 35 years, the real pull was the design of what we're calling the Duke Cancer Institute, which is truly a novel administrative structure. Those of you familiar with academic medicine or university structures in general know that things are very departmentally organized, that people work in a department of internal medicine or in a surgery department or in a pediatrics department, and it's very difficult to get people to work across departmental boundaries, sometimes because people are just too busy, sometimes because there's administrative structures that are in the way. With cancer, it is by definition a multidisciplinary disease. We need every discipline of medicine involved in the treatment of cancer. We need medical oncologist, radiation oncologist, surgical oncologist. You need the diagnostic imaging, the radiology. You need the pathologist. You need everyone engaged in making the diagnosis and doing the treatment and doing the follow-up. You need social work. You need every activity that goes on in a campus to add to the care of patients. The Duke Cancer Institute is a new structure at Duke and is novel enough that my guess is that as we're successful, other institutions will follow suit in this kind of setup where it crosses all of these typical departmental boundaries, where I have responsibility for the medical oncologist, the surgical oncologist, the radiation oncologist. They all work together within the Duke Cancer Institute in these programs. So they all work together on breast cancer or on colon cancer or on lung cancer. And they can work together because I provide an umbrella within the Duke Cancer Institute that gives them that protected time to do their research, to see their patients, to do the supportive care in ways that it's not that the departments didn't support them, but they weren't set up to organize them in that way. And so that was an extraordinarily attractive feature of coming to Duke for me and was in fact the selling point. The fact that we have the new Duke Cancer Center, this new building, it reflects this new structure because the clinics are multidisciplinary clinics. In one clinic, if you have breast cancer or you have prostate cancer, you go to one place and you see the medical oncologist, you see the radiation oncologist, you see the surgical oncologist, you have the social workers. You're not moving around trying to find all the different doctors and going all the different appointments. You just come in with your diagnosis and we organize that all around your diagnosis. So it makes it much, much easier for the patient, for their families. I can't tell you how often I hear from families, you know, it's not them that has the cancer, it's their parent or their child or their sibling, and yet they're taking them around to all these different appointments around the institution, around the city, around the country, and here we're providing that all in one clinic at a time when the patient and their family are going through the hardest times of their lives.
Well, when you walk into this building, if you haven't been there, you better come and see it. You walk into this building and there is this large fireplace there, right? So that's to say it's like a living room. It's not like a waiting room. And then you walk around, there are these sort of lovely wooden arches, vaguely reminiscent of Duke Chapel or something like that. And just all the spaces have a kind of inviting and calm quality to them. I'm just interested, you know, you can imagine, I imagine there must have been a day when the people who did research worked in one world and the people who had to care for the humanity of the people engaged in this suffering were in another world. What, from your point of view, is the meaning, the therapeutic value of having spaces like that? And the interesting thing about these spaces is this building was built by actually interviewing family after family. What would you have liked? What would you have wished instead? And trying to build everything on that model instead.
Well, you just answered the question, that it was designed specifically to take that stress away with getting input from the patients and from the staff. Patients would say things like, I don't want to wait in lines I don't want to see lines when I first come in the door. So you walk in and you don't immediately have the registration. You have a place that makes the patient feel like they're at home, which is what they ask for. It's a living room type setting. And each of the different clinics have their own waiting rooms that also feel like a living room with the TVs and the chairs and big open spaces. So it was designed specifically in response to what the patients ask for. Does it help patient care, or is it just for show? No, it actually helps patient care. Patients don't feel so stressed when they're in this kind of setting. They feel better supported. In fact, I can't tell you how often we've heard in the last few weeks from patients, I can't believe you built this for me. They feel it personally. They walk in and they feel like it's part of their treatment regimen now. Realize chemotherapy, radiation therapy, surgery are very hard things to go through. It's very challenging for the patient at many, many levels, from financial to medical. And to be able to take some of the burden off of the family makes them tolerate their therapy better. We can have higher cure rates if we can give full dose therapy. Patients will tolerate full dose therapy better if they're in an environment where the stress is reduced and the family is more willing to take them to all of their visits, be compliant. Not every family is as compliant as one might hope, and so the more you can provide support, the more effectively we can deliver full dose therapy, the higher our cure rates will be.
So if you were there for an infusion, you could go outside because there's a roof garden with like a lattice, and so it's kind of shaded, and yet it's like being outdoors. It's not like being in the hospital.
Right. That was specifically designed so that when patients are getting their chemotherapy, they can walk around in the spacious area and even go outside when it's a nice sunny day, or sit in the shade outside. But it again gives a different mindset to the patient getting the therapy.
Well, one of the words I've heard most often, you know, my career did not used to include presiding over large medical empires. And so I've learned a lot in this part of my job. And an interesting thing to me has been to learn the use of the word personalized as an adjective involving medicine, personalized care. And cancer is a domain, personalized meaning not just we treat you kindly as a person, but that there's an individual quality to the understanding and treatment of the disease.
Personalized medicine has perhaps its most important meaning in cancer because it can be personalized at every level. It's personalized in terms of your tumor. So not every lung cancer is the same. There are many, many, many different types of lung cancer, even when they look the same under the microscope. So we're now learning how to distinguish these lung cancers based on their genetic changes or other types of changes in the cells, and then have the therapy be specifically directed at those treatments. So personalized cancer treatment is aimed at the tumor. Personalized cancer treatment is also aimed at the person's own genetics, how you metabolize the drugs. There are some drugs that we give that are unfortunately toxic. Some patients tolerate them better than others. We're now able to start testing people for their own genetics and tell what dose of drug they can tolerate. So we give them the maximally tolerated dose so that it kills their tumor and yet doesn't have intolerable toxicities to the patient. So personalized is also at the level of the patient in terms of medicine delivery. Personalizes also in terms of the family needs, whether it's a person living by themselves or they have what kind of supportive structures they have, what kind of financial constraints they have, how far they have to travel. A lot of our patients come from 150 miles away or 200 miles away or from across the country. And there's different needs that patients have when they live locally versus when they're coming a long distance. So you personalize cancer therapy at every level, the tumor, the patient in terms of medicine, and the patient in terms of socioeconomics.
Well, and all of this is something we can do now and can aspire to do now that actually wasn't really even done to the same level 10 years ago, wasn't even possible to the same level 10 years ago. So here's the last question I want to ask you, and maybe it's a naive one, which is when you went into the study of cancer at a time when there was a lot of attention to it, but far less radical understanding than there is nowadays. Let's say we were to go that far forward. Give us 20 years, 25 years. What do you think the picture of cancer might be like 25 years from now?
I think our goal in cancer should be to get it to the point, in a sense, where tuberculosis is today. If you think about tuberculosis at the turn of the 20th century, in 1900s, we didn't know how to treat it. So patients would go into sanitariums and be isolated. It'd be a big burden on the family in terms of dealing with their loved one, and a big financial burden, and we didn't have good medicines. Then the antibiotic era hit, and all of a sudden we had therapies, and you no longer hear about tuberculosis as the same kind of deadly disease. But in 1900, it was consumption just like cancer was. Where we hope to be over the next 20 to 30 years is to have specific therapies that can selectively target the abnormalities in the tumor cell that do not have the toxicities for the normal cell. And in that way, to be able to control at worst and cure at best almost any type of cancer, where we get it to the point where people might get cancer, might die with cancer, but they don't die of cancer. And dying with cancer, it's not the same kind of effects that it would be now where you're dying of cancer. So to make it a chronic disease, will we ever cure all cancers? There won't be one drug that does it. Realize cancer is between 100 and 200 different diseases. Also realize the challenge of treating a cancer. If you have a tumor the size of my fist that has 10 to 50 billion cells in it, if you want to cure that tumor, you have to kill 100% of those cells. Killing 99.99% still leaves millions of tumor cells behind. It's an extraordinary challenge. And it is us. The tumor is us. It is a slightly modified version of us. So how do you develop a drug that selectively kills the tumor and not the normal cells? We are at that cusp, but we're able to design therapies that do that because we know enough about what's different about tumors. So 20 or 30 years from now, we will have those specific drugs. We'll be able to give them. We'll be able to control or cure the cancer. So patients are now dying of happiness at 120 is the goal.
I'll have a, yeah. It's a pretty great last line. You know, at Duke we talk a lot about this phrase, knowledge in service of society. There are many forms of service that can be done by people without specialized training, but you know, cancer can't be cured by people without specialized training. And so what we understand is, if and when we reach the much better state you describe, it's not going to happen by itself. It's going to happen by the work of understanding, the focused work of research and cure that you are leading. And I thank you for the fact that Duke will be in the forefront of this movement.
Thank you. It's a privilege.
Let's throw this open. We rode down here together and we had a funny exchange to the effect. In the middle of the financial downturn, I used to interview financial gurus in this setting. And the question period was always funny because every question could be deciphered as, how can I become rich again or for the first time? And for you, there is a tendency to ask questions, you know, because everyone in this room, there's no one in this room who does not know at first or second remove someone who has suffered some version of what we've been talking about here. But let's throw it open. Some questions for Mike Kasten? Here's one.
What collaboration have you got with the North Carolina Research Institute in Kannapolis?
in Kannapolis. So we're very involved in the biomarker factory and the biomarker activities which are part of the Murdoch facility. And in fact, I saw David Murdoch this morning, and we discussed opportunities to enhance our visibility on the campus. But right now, that campus hasn't seen its potential yet. And there's a lot of reasons for it that we could discuss in other forums, but we are talking with him about ways that we can leverage activities at Duke with activities on that campus. But it still has a long way to go, not only in terms of what Duke is doing there, but also what UNC and North Carolina State are doing there. All three institutions have some visibility there. North Carolina State and UNC a little bit more because they were state-funded facilities that are on that campus.
Mm-hmm. Sir.
Mike, I just mentioned tonight that my wife has had cancer. My 5-year-old grandson is currently fighting cancer. And I just want to thank you for what you're doing. And it touches a personal note with me. And then I want to say to you that while I only met you tonight, you seem a lot smarter than Michael Marsicana had told me.
Who is nevertheless very smart.
Now, Dick, I don't want to leave you out of this. I think you know from conversations that we have had that I have great admiration for you. And tonight, your stock went up with me because I met Cindy, and I'm convinced that you married better than she did.
I would only know that that was not a question. Here's one.
Hi. We're in the midst of a presidential election year, and obviously healthcare reform is being challenged. We know at the Supreme Court level in June. And can you comment, please, on what Duke is doing to care for the uninsured or underinsured in the fight against cancer?
The question is not fair coming from an old high school classmate, but I'll answer it anyway. So we consider ourselves the site for health care for everyone in the Durham community and in the Triangle region who needs it. And we do everything we can to take care of the uninsured. There's some variability in the different disciplines in terms of how well that's done. Within cancer, we pay particular attention to it. In fact, I was telling President Broadhead on the way down, we've just hired a new director of health equity within the Duke Cancer Institute to help us with our outreach in the Durham community, both in terms of taking care of the patients as well as enrolling minority patients on clinical trials, because historically they have not participated in clinical trials as actively, which means they don't get next generation therapy as often. So we're working very hard to create equity across the board. Healthcare reform is a tough issue, and I hope we'll get to the point where we can give everyone equal care without breaking the bank individually or as a country.
I'd only say about that, I know from my many meetings on the board of the Duke Health System and things of that sort, one used to hear of the great number of people who don't have health care, but you know that people without health care can go receive health care at places like the Duke Emergency Room and places like that. It's an extraordinarily inefficient and unsuccessful way to deliver health care. We have never withheld, Duke's burden of unreimbursed care has always been very, very high, and we regard that as an important part of our mission. You would be solving a problem. I mean, if you got to the point where actually there was some better system than that, what this is actually going to mean for reimbursement, for the way the system works, of course, is a matter of great uncertainty to all of us. But we'll see if we can bring out a good result.
I would also add that one of the ways we're trying to address healthcare cost is to more effectively partner with hospitals and practices around the region, around the state, around the country, so that we can we can provide better care and more equalized care in all of these places. And in some ways, we may end up saying, okay, if you have this particular type of intervention, that's better done at this hospital in the system.
Right.
If you have this type of intervention, it's better done at this hospital in the system. So ways to actually cut cost. The other way to cut costs that I keep arguing for is research that leads to more effective and less toxic treatments. And as I mentioned before, the example of tuberculosis, now antibiotics treatment, it's much less costly than it was when people had to go to sanitariums. We get to that point with cancer, it'll be much less of a financial impact on our healthcare costs.
And now can I ask you a question? What was he like in high school?
I could tell lots of stories, but it may keep us too long.
I saw another hand, please. Your Honor.
We've already heard about the program at Kannapolis, and I believe it's in great part involves nutrition. What significance do you attribute to diet or nutrition with respect to the prevention of cancer or the improvement of cancer once it's got?
Great question.
It's a wonderful question. Did everyone hear the question? The question was about what's the contribution of nutrition or poor nutrition in cancer development and even in how one responds to therapy or keeps the tumor away once it's has been effectively treated. I would first tell you that epidemiologic data, population science studies have shown that 80% of all human cancers are caused by, or at least have a contribution of some sort of environmental exposure. 30% of that is smoking. So if you want to have the biggest impact on lowering cancer incidence, you stop smoking. If we could do that, 30% of cancers go away immediately. So then you have another 50% that are caused by other types of exposure. Some of that are clearly chemicals in the environment and other types of exposure, sunlight and natural radiation and other things that you're exposed to. But then the third component of that is diet. And the problem is we don't know how big of a contribution diet makes to most cancers. There are studies that say, yes, high-fat diet or being obese contributes to certain types of cancers. You know, there's breast cancer and prostate and hormonal cancers where if you're overweight, that there seems to be a higher incidence or a later stage diagnosis in those cancers. But it's been very hard to pinpoint specific things in the diet that are direct contributors. That being said, moderate diet, well-balanced diet, not being overweight, we know that health in general is better, including lower cancer incidence. But how it contributes directly to what you're eating, we don't know. Certainly the other big component is genetics. We all know people that smoke for 40 years, 2 to 3 packs a day, that don't get lung cancer. In fact, 85% of heavy smokers don't get lung cancer. That means only 15% do. Now, I'm not arguing that smoking is a good thing, because 100% of those people will have heart disease and lung disease. But only 15% of them get cancer. That means that they had some genetic predisposition in terms of how they dealt with the carcinogens, with the cancer-causing agents in the cigarette smoke. So every cancer is caused by a combination of what you're exposed to and what your personal genetics are. The problem is we can't always distinguish those.
But what of the improvement of cancer once it's obtained? Is there
A dietary.
evidence that shrinking of cancer or improving its effect might result from some diet?
So there's no proven studies where that has been true. You certainly will hear anecdotes. You'll hear people say, I had my cancer cut out and then I went on a great diet and it never came back. But cause and effect has been very difficult to prove in that regard.
I refuse to let that be the last question before we have dessert, so let's take one last. Sir.
Thank you, Mike. Brian Crutcher, Trinity, 1966. It's my simplistic understanding that cells do two things, replicate and differentiate. And I understand that Dr. Breslau of University of Pennsylvania was the developer of a drug, I believe today it's Merck's name is Verinostat or something like that have the propensity of preventing the replication. And I wondered if if there's any validity to that, and if it's in use at the Duke Cancer Institute. Thank you, sir.
So actually, let me amend your comment. There's actually three things that cells do. They grow, they differentiate and stop growing, or they die. And so for years, everyone thought that the way to treat cancer was to stop them from growing. So most of the therapies we use, the chemotherapies and most of the radiation therapies, work because they kill cells that are rapidly dividing. But about 20 years ago, we learned that cancer is much more complicated than that, that the other thing that cells do is die. And what cancer cells don't do is die. So normal cells, once they get to a certain stage, they actually die. They actually have a suicide mechanism. This is one of the things that the p53 gene does, is it tells cells when to die. So when it's missing, cells don't die, and so you get a tumor. So it's much more complicated than simply stopping the growth of cells. So that will slow down the tumor. It may even stop it for a while, but it usually is not curative in and of itself. What we have to do in order to cure cancers is to trick them into killing themselves, to turn back on these suicide mechanisms. So this is where most of the new therapies are at affecting the biochemistry of the cells so that they actually commit suicide. And that's the wave of the future and has been the main focus of recent research.
So I just want to say, the next time you see somebody getting on a school bus to go to a local high school, you can squint your eyes and say, that could be Mike Kasten 20 years from now or 40 years from now. I mean, to me, it's a pleasure to be with someone doing such extraordinarily important work as you. But the notion that we have come back to the place where the education started that put you on this trajectory, that's a special pleasure. So please, thanks for your presence.
Thank you.
Produced by Duke University. Online at duke.edu.